Okay, so we're going to start the hour here on the video for grading the 5-question quiz. The first one was to graph, and you're going to grade your own here. I'm going to graph y equals sine of theta, and you should look for, first of all, the wave should generally go up and down like that. How high? 1 and down to -1. And you should have these spots labeled here, 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 and here. So this is 2 pi, this is pi, this is 1 pi over 2, and I think the smart way to count it is like this, 2 pi over 2, 3 pi over 2, and this is like 4 pi over 2. I totally get that you might have just said 2 pi instead of 4 pi over 2. There is the graph of sine. Raise your hand if you had that one right. Okay, cool. That should have been a nice easy point. Now on to number 2 is graphing cosine. I'm just going to put it on the same graph. So cosine starts here and ends here, and it goes down. I know it's hard to track, but look at here. Maybe I'll make it have black spots in the line. That dotted line that's on top of the blue line, that's what your cosine should look like. Starts at 1, ends at 1, like a big valley. That should have been pretty easy too. Any questions on sine or cosine? Okay, on to number 3. On number 3, I asked you to graph y equals 2 sine of 3 theta. And that's going to involve starting with sine. So sine starts looking like that. And all of these spots are labeled, but I'm not going to label them because I'm just going to have to relabel them. That 2 right there tells me to label this with a 2 and a -2. Raise your hand if you had that part right. Okay, good. Then on to the next part is where this should have been 2 pi, and this should have been pi, and this should have been pi over 2, but you relabel them with, instead of multiplying everything by 3, you don't trust it. It's on the inside. So you multiply everything by 1/3. And so if you put a 1/3 in front of all of these, that would help, but your actual, if you didn't actually multiply them out and get pi over 6, 2 pi over 6, which I know it reduces, if you didn't actually multiply these out, then you have to lose a half a point. If everything else was perfect, but you didn't multiply them out, then you lose. So I personally would have left them this way. I know some of you probably reduced them, but it just flows so nice to say 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Okay, that was number 3. Number 4 had negative cosine theta plus 1. So a lot of people knew to move this graph up 1, but to first start with, I have to actually get cosine on here. Cosine is a valley. And it ends at 2 pi. Now, this flip and this move up 1, it doesn't really matter. Actually, no, it does. I think if you didn't flip it first, you would get it wrong, because it's a multiply in front and that's an add. Multiplies are supposed to go first, so I'm going to do my flip first. There, now it's the green one. And then a surprising number of people were like, well, I don't know, I guess I'll just make up how far 1 is. You can't just make up how far 1 is. You know that distance, however tall you made that distance is 1. So when you moved this up, I think a lot of you just kind of like moved it up something, and you didn't think about how far to move it up. But you know how far 1 is. It's that far. So it should have moved up that far, 1 mark. That far, and this will go up that far, and this will go up that far. To me, I've done a lot of these now, and I think that the little arrow thing is a great way to go, because you can really tell where you moved it. And it should be sitting right on top of the x-axis now. Okay, so if yours was like partway up, like right there, you really didn't move it up high enough, because we know how far 1 is. It's from the origin to that first mark. That's how far 1 is. All right. Now, I know a lot of you had the right idea, but you didn't move it up enough. You're going to have to lose a half point. if it had the right curve, but it wasn't moved up far enough. All right, and last question was number 5, and it specifically said don't graph it. You just had to tell me on number 5 what the amplitude and stuff was. So here's our y equals -5 sine of 4 theta. And the amplitude is, it's not negative, it's just 5. If you forgot and put a -5, you're going to lose a half a point. Amplitudes can't be negative. Next little thing is period. Well, I gave you a formula for this, 2 pi over b. But you have to like know what b is and put it there. B is 4, so 2 pi over 4. Now, I had other kids do this other ways. Like, I had an 4 pi over 8. Well, that's the same thing, it's just not reduced. And mine isn't reduced, so I can't really be mean about reducing. If you did reduce, that'd be pi over 2, and it's okay, but you didn't have to. All right, and then the last part was phase shift, and I had said that there are no phase shifts. So if you made up one, that's a bad idea. There was not a phase shift in this. That 4 is not a phase shift. That is a stretch. A phase shift would look like if they put minus pi or something like that on the inside. That would have been a phase shift, but this one had none. All right, now I give yourself a score out of 5. I am curious how many got the perfect 5 out of 5. How about 4.5 out of 5? How about 4 out of 5? All right. So if you made mistakes, do you have any questions about any of these? Like, why is this one this way? Any questions? Okay, that's where you're supposed to be so far. Now, what I need to teach you next, you can slide back into your normal rows at this point, and I'll teach you a little more. So, do you get in this problem, they are asking you to move it. Well, a lot of times they ask you to move it, but this one is called a phase shift, and they want you to move the graph to the right, pi over 2. All right, I'd like you to actually get this. This is the worksheet for today. We're just going to work through a few of the problems with you, and then hopefully you'll get, good at it by just doing a couple with me. And then I think I'm going to do the first couple and then assign you 1 through 6 is my current plan. Okay? All right, so find this worksheet and start by graphing regular sine. Now, I personally think they look better if you make that 1 and that -1. You don't have to. You could have graphed it not going up that high. And I think I'd go every 2 marks and say this is 2 pi and this is pi, pi over 2, 3 pi over 2. Since we have plenty of room, there's no sense in making a teeny tiny graph. So sine starts by rising up really fast. It gets to its peak. And it goes back down. And then it goes down to its lowest spot. And it comes up back up to 0. So there's sine. So honestly, don't try to go right to the answer. Start with regular sine, and then we will shift it. The first thing you should do in your notes is to say plus is left, minus would be right. So these phase shifts, it matters which way you shift it, right or left. In this case, we're going to shift it to the left because it's a plus. And just like last time, you can't just make up how far pi over 2 is. We know how far pi over 2 is. It's that far. That's how far pi over 2 is because it says pi over 2 right there. So that's how far you need to shift it. So if I need to shift it left, pi over 2, then my favorite way of doing this is to go, I'm going to take each of these points and go left and try to keep these arrows the same distance, which is 2 marks. That's how far pi over 2 is, 2 marks, see? So I'm going to take all the key spots on this parabola, which are like its x-intercepts. I'm going to move them over 2 spots. And this bottom spot, the place where it reached the very lowest it was, that goes over 2 spots. And then your answer, I like to put a dot for each of these new spots. There, 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 and there. And then I just have to connect the dots. Now, do you see that if I leave this original graph on here, that'll be kind of confusing. I'm going to erase out my original sine graph. Now, look at this answer, and do you get why one kid last hour walked up and said, Mr. Server, the key is wrong? They graphed cosine, because see, they have a peak right there, and they graphed cosine. No, this is sine that's been shifted over. Would you agree, though, that if I extend this graph out a little bit, it looks like cosine? Doesn't it look like cosine? It's got the peak here, and it's got the peak here, and so that's because shifted sine is cosine. That's where cosine is. So these can be confusing when you look at the key, because you're like, what, I thought we were graphing sine. Yeah, but when you shift sine, it looks like cosine. All right, so your final answer is this blue equation, and it does kind of look like cosine, because at 0, it's 1. But that's because sine is shifted cosine. All right, same idea. If you take cosine and you shift it, it's probably going to look like sine. So don't be shocked when the key looks like a different function. All right, so you start graphing regular cosine. It doesn't take too long to label these things properly. Took 30 more seconds, and now I'd get credit for it. Without labels on your test, you won't get any points. Now I gotta shift it. That means right. Right pi over 2. How far is pi over 2? I know that. It's this. That's how far a pi over 2 is, see? Because we labeled it. So here it's two blocks again. If I go right 2 blocks for each of them, lowest spot goes over 2 blocks. The other x-axis or x-intercept goes over 2 blocks. This goes over 2 blocks. On my new graph, I'll make black dots for this. Now, when I erase out the original, it is going to look a little confusing. If I connect this, I'm just going to add a little piece on right there to continue the pattern. And doesn't it look like sine now? It starts at 0. So kids get confused. They're like, but I thought we were graphing cosine. Yeah, but if you shift cosine, it looks like sine. Sometimes. Okay. So sometimes they're going to have you shift it pi. But if you're labeled in pi over 2s, you should be able to go, oh, 2 pi over 2s is like pi. So maybe you have to shift it over 2 spots. All right, and your assignment is to do 3 and 4 and 5 and 6 with your partner. And that's all you got to do. Very doable assignment today. And I did double check, and the key is correct for problems 1 through 6. So that's all I got for you for today.